Today's video focuses on factoring polynomials. If you haven't done so already, I want you to go back to Google Classroom and watch the videos that I posted to refresh your minds on factoring of quadratic functions. This is when we factor using the GCF, when a does equal 1, when a does not equal 1, and our special cases as well. This is very important that you have a strong foundation for factoring before you watch today's video. If you've already taken the opportunity to watch those videos, we're ready to begin. I would like for you to pause the video and try the matching activity, so numbers 1 through 5, and then hit play when you are done. On the matching activity, the first question was 4x squared minus 3x plus 81. There's actually two ways you could have approached this. Some of you may have recognized that this is a problem where a does not equal 1 and would use the box method. Remember, if you're trying to use the box method, what you would do is you set up a box and cut it into 4 smaller squares. Your first term would go in the first box, your last term would go in the last box, and then you would multiply those two things together. If you do that, you get 324x squared. Then you'd have to list out all of the factors of 324 and try to find a set of factors that would give us the middle term of negative 36x. Just to save us some time, I'll write that those terms were a negative 18x and a negative 18x. They both must be negative because I want a negative 36, and I know that I have to use same sign since this was a positive value. I'd put my negative 18x here, negative 18x here. Then you would pull out the GCF for each pair, so each vertical pair and each horizontal pair. Starting here, the GCF would be a negative 9 because there's a negative outermost box. Next, with the 4x squared and the negative 18x, it would be a positive 2x because this is a positive outermost box. Once again, GCF here would be 2x, GCF here would be a negative 9. So we end up with 2x minus 9 times 2x minus 9, or that is 2x minus 9 squared. Another way you could have approached this is recognizing that this is a perfect square trinomial. Something is a perfect square trinomial if the first term is something squared, the last term is something squared, and then the middle term is 2 times a times b. So if I take a look at number 1, 4x squared is a perfect square of 2x, because 2 squared gives me 4, x squared gives me x squared. And then 9 is, 9 squared would give me that 81. And then the 36x could be achieved by multiplying 2 times 2x times 9. So again, this is a perfect square trinomial because it is in the form a squared minus 2ab plus b squared. And I would rewrite that as a minus b being squared. So that means that the answer here is 2x minus 9 being squared, which is what we found over here. It's worth mentioning that if it would have been a squared plus 2ab plus b squared, that's equivalent to a plus b being squared. This was in the special cases video that I've reposted. It also is in my YouTube channel if you go through my videos. Looking back at today's notes, it looks like D is the answer. Number 2, we have 3x cubed minus 6x squared plus x minus 2. We have 4 terms, which means we want to factor by grouping. Remember, when you factor by grouping, you pair the first 2 terms together and then the last 2 terms together, and the goal is to make the parentheses look the same after we pull out a GCF. So looking here, my GCF would be a 3x squared, which leaves me with x minus 2. This parenthesis looks just like this parenthesis, and there is no GCF other than 1 between these 2 terms, so I would just put plus 1 and then keep that x minus 2 the same. Now we can see that if I pull out the x minus 2, I am left with a 3x squared plus 1. We always want to check and see if I can factor any further, and in this case, my 3x squared plus 1, I cannot factor any further. So this is the answer. Taking a look, that would be B. Number 3, we have 27x cubed plus 216. When you're attempting this problem, the first thing that I notice is that I have an x cubed and a constant. That's usually an indicator that we're going to have a sum or difference of 2 cubes. Because this is addition, I know that I have the sum of 2 cubes. So we have to ask ourselves, what cubed would give me this, and what cubed would give me this? Well, 3 cubed would give me 27, x cubed would give me x cubed, and then 6 cubed would give me the 216. So this is my A, the 3x, and my B is 6. And I would just plug it into the formula or the rule for the sum of 2 cubes. I'll go ahead and rewrite it for you real quick. If I have A cubed plus B cubed, that's equivalent to, remember the sum and difference both have A and B in the first parentheses. Scooch it over here. And then in the second parentheses will be a trinomial of A squared, AB, and B squared. The only difference is their signs. So if it was minus, it would be minus plus plus. But because this is a plus, it would be plus minus plus. Okay, so that means I'm just going to plug in my A and B. I have 3x plus 6. And then here I would put my A being squared. So 3x squared, I distribute the power because it's multiplication, I can do that. So 3 squared is 9, x squared is x squared. Minus A times B, so 3x times 6 is 18x. Plus my B squared, so 6 squared is 36. Now, we do want to see if we can factor this any further. This doesn't mean that we're done. So the 3x plus 6 can be factored further. I want you to notice that there is a GCF here of 3. So if I pull out a 3, I have x plus 2. And when I look here, I also have a GCF of 9. So I can pull out a 9. Remember, this is multiplication between the two. So times 9 times x squared minus 2x plus, that would be 4. We're not done yet. I can clean this up a little bit more. 3 times 9 is 27. I have 27x plus 2, x squared minus 2x plus 4. And if I were to take a look at my options on the matching activity, E would match number 3. That was a harder one, I will admit that. Let's take a look at number 4. We have x to the 6th power plus 3x cubed plus 2. Now, this one does look a little bit different than what we're used to. Normally, when we have a trinomial like this, we like to see x squared, x, and then a constant. We're going to treat it the exact same way, okay? So really, I'm going to, again, treat it like a quadratic, and I'm going to use guess and check because a is 1. I know that the factors of 2 are 1 and 2. Using same signs, if both of them are positive, I can get that middle term of 3. So I know when I set up my guess and check, I have a +2 and a +1. Now instead of putting x and x here, because x times x is x squared, I would want to use an x cubed. Because x cubed times x cubed times x cubed is equivalent to x to the 6th power. When we multiply variables, we add the exponents. Now, I need to check and see if I'm done, and no, the answer is I am not done. This is actually a sum of 2 cubes. Notice how x being cubed would give me x cubed, and 1 being cubed would give me 1. The x cubed plus 2, this is not a sum of 2 cubes because nothing cubed would give me 2. So I can simplify this further. Again, sum of 2 cubes. So my final answer, I'm just going to leave that x cubed plus 2 alone and then set up my x cubed plus 1. I have a squared, b squared. So x, 1, x squared. X times 1 is just 1x, or x, and then 1 squared is 1. Because it was the sum, I know that it is a plus, minus, plus. Again, if it was a difference, it would have been minus, plus, plus. Now we have factored it all the way. You could check and see here if we factored any further, but the factors of 1 are 1 and 1, and using same signs, there's no way I can get to a -1. So this is our final answer, and that corresponds to A. Last one, number 5. This one was pretty straightforward. It was just a basic difference of 2 squares. A would have been a 3x and B was 4. The difference of 2 squares rule, if I have a squared minus b squared, it's equivalent to a plus b times a minus b. So this would be a 3x plus 4 and a 3x minus 4, which corresponds to C. I do want to point out that had it been 9x squared plus 16, this would have not been factorable because of that plus sign. Only a difference of 2 squares can cancel out to give us that 0x.